We're going to use the same method to solve this inequality, and this one's a little challenging because it's going to use a lot of the techniques that you've talked about before. So the first thing we need to do is separate this into two cases. So case 1, pardon me, wrong pen, is the case where x plus 1, what's inside the absolute values, is greater than or equal to 0, and case 2 is the case where x plus 1 is less than 0. And of course this makes it easier to rewrite the inequality by considering the cases separately. And any x which gives us a solution here gives us a solution to the original inequality, and also the same for case 2. If I have an x value which gives me a solution under this condition, it is a solution to the original inequality. So the solution set to the original inequality is going to be the union of these two solution sets. Let's see what happens in case 2 first. If x plus 1 is less than 0, I'm looking for all values of x so that x plus 1 is less than 0 and its absolute value is greater than or equal to x squared over 4. Now the absolute value here is minus x plus 1 because it's less than 0, and I'm looking for x values where that's greater than or equal to x squared over 4. I'm going to translate this to x less than minus 1, and I'm going to multiply by this minus here to get minus x minus 1 greater than or equal to x squared over 4. I'm going to multiply everything here by 4. Doesn't change the greater than or equals, so I'm looking for all x values so that x is less than minus 1, and minus 4x minus 4 is greater than or equal to x squared. Now this is going to be a quadratic. If I bring everything over to the right hand side, and I can solve it using factorization. So I'm looking for all x values where x squared plus 4x plus 4 is less than or equal to 0, and x is less than minus 1. Now notice that this thing factors very easily, and both factors are equal to 2. So this is x plus 2 squared less than or equal to 0, and x less than minus 1. And in case this is confusing, I'm going to switch it around here. I'm going to write it this way: x plus 2 squared less than or equal to 0, and x less than minus 1. Now, a square is never less than 0, so the only possible solutions here are the x values for which this is equal to 0. So the solutions here are x equals minus 2, and I also have the condition that x is less than minus 1. So the solution in case 2 is the set of all x values which satisfy both of these conditions. So it must be x equals minus 2, and x must also be equal to be less than negative 1. So the intersection of the set of all x which are less than negative 1, that's from negative infinity to negative 1, and x equals minus 2 is just minus 2 itself. So the solution set here is just a single number. It's x equals negative 2, or another way of writing that is just the set with the single value negative 2. Okay, well that takes care of case 2. Case 1 is going to be a little more complicated. So here we will have, again, two conditions. We have x plus 1 greater than or equal to 0, and now our original inequality gives us x plus 1 greater than or equal to x squared over 4 because the absolute value of x plus 1 in this case is just x plus 1. And again, we use the quadratic approach here. This gives us x greater than or equal to negative 1. And the other restraint is that, or constraint, is that 0 is greater than or equal to x squared over 4 minus x minus 1. Now I'm going to multiply this thing by 4 to make it look more reasonable. So I'm looking for all x values so that x is bigger than or equal to minus 1. And 4 times 0 is 0. So I get x squared minus 4x minus 4 less than or equal to 0. I need to find the factors of this thing. So I'm going to use my quadratic formula. I have minus b plus or minus the square root of b squared minus 4ac all over 2a. Well, it's going to be 4 plus or minus the square root of b squared is 16 minus 4ac is going to be minus 4 times minus 4, so it's plus 16 all over 2. So it's going to be 2 plus or minus the square root of 2 times 16 is 4 times the square root of 2, and divide by 2, I get 2 times the square root of 2. So these are the factors, or the factors of x squared minus 4x minus 4 are x minus 2 plus 2 times the square root of 2 and x minus 2 minus 2 times the square root of 2. So I'm looking for all x values for which x is greater than or equal to minus 1 and 0 is greater than or equal to x minus 2 plus 2 times the square root of 2 times x minus 2 minus 2 times the square root of 2. In order to figure out where this thing is less than or equal to 0, I have to analyze the factors. First I find where they're equal to 0, and this is easy. They're equal to 0 at 2 plus 2 times the square root of 2 and 2 minus 2 times the square root of 2. So I draw my number line. And I put in the points where the factors are equal to 0. And then this splits my number line into 3 subintervals. From 2 plus 2 times the square root of 2 to infinity, 2 minus 2 times the square root of 2 to 2 plus 2 times the square root of 2, and from minus infinity to 2 minus 2 times the square root of 2. Those are my intervals, and I need to check the sign of this product on each of those intervals. So the sign of each of the factors, x minus 2 plus 2 times the square root of 2 and x minus 2 minus 2 times the square root of 2, the sign of these is going to determine the sign of the product. Of these two factors. X minus 2 plus 2 times the square root of 2 is going to be positive for x bigger than 2 plus 2 times the square root of 2 and negative for x less than that. X minus 2 minus 2 times the square root of 2 is going to be positive for x bigger than 2 minus 2 times the square root of 2 and negative for x less than that. And then when I take the product, I have plus by a plus gives me a plus, plus by minus gives me a minus, and the product of two minuses gives me a plus. So we have, we're trying to solve the simultaneous equations x greater than or equal to -1 and x minus 2 plus 2 times the square root of 2 times x minus 2 minus 2 times the square root of 2 less than or equal to 0. And so this is going to happen when x is bigger than or equal to -1, so that's -1 to infinity. And since the x values have to satisfy both inequalities, I'm looking for the intersection of the solution sets. The solution set to this one is all x values between 2 minus 2 times the square root of 2 and 2 plus 2 times the square root of 2 on that closed interval, because at the end points this is equal to 0. Now the question is, where is -1 in relation to 2 minus 2 times the square root of 2? Is this bigger than -1 or less than -1? If it's bigger than -1, this interval is contained in the interval between -1 and infinity, and the intersection is just this interval itself. So our big question is 2 minus 2 times the square root of 2 bigger than -1? While rearranging, what I'm asking is 2 plus 1 bigger than 2 times the square root of 2? Or is 3 bigger than 2 times the square root of 2? How can I tell? Well, I can square both sides. And I'm asking, is 9 bigger than 4 times 2? And the answer is yes, 9 is bigger than 8. So that means that 2 minus 2 times the square root of 2 is bigger than -1, and this intersection is just the interval 2 minus 2 times the square root of 2 to 2 plus 2 times the square root of 2. So that's my solution set to case 1. And so the solution set here is 2 minus 2 times the square root of 2 to 2 plus 2 times the square root of 2, that closed interval. And the solution set to my original inequality is the union of the set of solutions from case 1 with the set of solutions from case 2. So it's everything between 2 minus 2 times the square root of 2 and 2 plus 2 times the square root of 2 inclusive, along with the number -2. And that's the entire solution set to this inequality.